Hello everyone, my name is Tymon Nieduzak. I'm a mechanical engineering master's student here at UMass Lowell, and I'll be presenting today our work on wind turbine monitoring using optical motion magnification. Large-scale structures like buildings, bridges, and wind turbines in our case require consistent monitoring in order to ensure they're operating safely. This is called structural health monitoring, or SHM. Now, we typically rely on things like visual inspections or destructive testing like excavation or penetrant testing, which can be seen in the images on the left and in the middle. There are also traditional sensor-based approaches, as can be seen on the right, in which transducers like strain gauges or accelerometers are used to generate time waveforms. Now, arguably, this data is not very reliable in determining structural integrity, and these techniques are very slow and expensive. So, we decided to investigate a non-destructive, non-contact SHM technique called optical motion magnification, or OMM. This technique can extract imperceptible motion without contacting the structure, generating displacement time waveforms from which frequency content is extracted. It also generates qualitative motion magnified videos, which are an invaluable resource. Here's an example. In the video below, not much motion can be seen, and both base plates appear to be of similar health. However, once we magnify the motion, the points of largest displacement are clearly seen, and the left base plate is identified as having more damages. So we applied this technique on wind turbine foundations. The original video, seen on the left, doesn't really show any motion, but once we magnify it, as seen on the right, we can easily see the displacements. Now, if we record the foundations at similar angles to the wind and during similar wind speeds, we can compare the videos of different foundations. Here, we see two wind turbine foundations of differing health. Both videos were taken at similar working distances and at an angle about parallel to the wind direction with similar wind speeds of 12 and 10.9 meters per second. Both videos were then magnified by the same level and compared side by side. Purely qualitatively, you can see that the wind turbine foundation on the left is clearly moving less than the foundation on the right. This conveys that the health of the foundation on the right may be in question. This same conclusion is reached when comparing the quantitative displacement time waveforms. The foundation on the right having a root mean squared value of 0.78 millimeters, while the foundation on the left had a value of 0.29 millimeters. Overall, this technique shows a lot of promise for the application of wind turbine structural health monitoring, and ideally, future works will further this research by testing larger sample sizes and improving the optimal testing procedures. Thank you.